Hello and welcome. This video, let us discuss a basic concept in algebra, which is completing the square method. This method is applied for quadratic polynomial to find the roots of the quadratic equation. This you might have studied this in class 9 or 10. Let us look into this concept again. Let us get familiar with this concept because this concept is very helpful for us to find the range of quadratic polynomials. So let us take an example. So I'll take an example. I'll take a quadratic polynomial. F of x is equal to x square plus x plus 1. So why this method is called completing square method? So there is a good reason for it. Let us take the formula a plus b whole square. A plus b whole square is a square plus b square plus 2ab. So if you look at this equation, we already have a square term. So I'll treat this term as a square, and we have a here. So somehow if I make it 2b, if I make it 2ab, so then I'll get a partial part of this a plus b whole square. So if you take these two terms only, it is not a square, it is an incomplete square. So to make it a complete square, I have to add a term called b square. So then only I can make this whole thing a complete square. That is why this method is called completing square method. So let's see how to do that. F of x is equal to x square plus, so this we have to make 2ab. So what I'll do is I'll take 2, a is any of x. Then how to find b? So b is, how to find b is equal to, you have to take the we have to take half of the coefficient of x. The coefficient of x here is 1, so half of 1 is half. So why we have to take half of coefficient of x? Because this half and the coefficient, these two will get cancelled out, and we'll get back the original x. So uh, this will not corrupt the balance of the equation. So that's why we have to take 2 into x into half of the coefficient of x plus. So now this is my b, this is my b. So I have a square plus 2ab. I have to add b square. So b square is 1 by 2 square. So since I have added 1 by 2 whole square to the equation, now again the equation becomes imbalanced. So to bring it to balance, I have to subtract whatever I've added to this equation, which is 1 by 2 whole square minus 1 by 2 whole square. And finally we have this 1 at last. So I'll add 1. So now I have essentially completed a square. So these three will make a square because this is a square, this is 2ab, and this is b square. So from these three terms I can write a is x and my b is half, so x plus half whole square, and this is minus 1 by 4 plus 1. So here this is equal to x plus 1 by 2 whole square. To simplify these two, what I'll do is I'll take plus here and I write everything inside a bracket on minus 1 by 4 plus 1. So I'll simplify this separately. So I have minus 1 by 4 plus 1. I'll take LCM, minus 1 plus 4 divided by 1, which is 4 minus 1 is 3, 3 by 4. So f of x is x plus 1 by 2 whole square plus 3 by 4. So this is the standard form we have to bring. This is the standard form to which we have to bring the quadratic equation to. Let us solve one more problem. F of x is equal to minus 2x square plus x or plus 3x plus 2. So to apply completing square method, we have to make sure that the coefficient of x square should be 1. In the previous problem, the coefficient of x square is 1. so it did not give us much trouble. So here the coefficient of x square is -2. So before applying completing square method to any quadratic polynomial, we have to make sure that the coefficient of x square is always 1. So here the coefficient is -2. How to make the coefficient of this quadratic polynomial 1? Just take -2 common. So if I take -2 common, this becomes x square, and this plus becomes minus, and this becomes 3 by 2 because I have taken 2 outside, x, and plus becomes minus because -2 is a coefficient, and 2 by 2 is 1. So to verify whether we have written it properly or not, just try multiplying -2 to the whole thing inside this bracket. You have to get back this equation. This is 3 by 2. So now let us complete the square. This is equal to -2 x square minus, so what I'll do is I'll write 2a, and we have to find b. How to find b? The coefficient of x over here is 3 by 2. Half of 3 by 2 we should find. Half of 3 by 2 is 3 by 4. So this I'll write 3 by 4. So now you can see, if you cancel this 2 with this 2, you get back this same equation. So whatever we have done is right. Minus, now we have this is my a square, this is 2, this is a, and this is b. So I have a square minus 2ab. Now I want b square. So what is b square? B square is, b is 3 by 4. Now I know 3 by 4 whole square. Since I've added 3 by 4 to the equation, I have to subtract this with 3 by 4 whole square. So if you don't want, you can cancel these two, and the equation becomes equation returns to the equation returns to its previous state. And -1 we have from here. So from these three terms, I can write this is a square, this is b square, minus 2ab. So this is a square plus b square minus 2ab is a minus b whole square. So this is x minus 3 by 4 whole square, minus 3 by 4 square is 9 by 16, minus 1. So let us make sure everything is right. Yeah. Okay. So now -2 x minus 3 by 4 whole square. Since both the terms are negative, I'll take negative outside and put everything inside the bracket. 9 by 16 plus 1. So I'll simplify this 9 by 16 plus 1 somewhere here. So if I take LCM in 9 by 16, 16, which is 25 by 16. So f of x is -2 into x minus 3 by 4 whole square minus the term over here is 25 by 16. Next, what we have to do at the final stage is, whichever number you have taken out in the beginning, you have to bring it inside. So I'll multiply this -2 to both the terms inside the bracket. So -2 times x minus 3 by 4 whole square, minus into minus is plus, 2 into 25 by 16. So 2128. Finally we have equation f of x is equal to -2 into x minus 3 by 4 whole square plus 25 by 8. So this is the standard form. This is what we have to achieve whenever a quadratic polynomial is given. So having studied this method, we can see how we can apply this method to find the range of quadratic polynomials in the coming videos. Thanks for watching.